Learning Planet Institute.
Welcome to R&D Unplugged, a podcast from the Learning Planet Institute dedicated to discussing with researchers on the impact of their work in a simple way. My name is Annalena, I'm your host of today, and I'm here with our guest Jean Vassoyan. He's a graduate of Telecom Paris and of the Mathematics, Vision and Learning Master's program. He's currently pursuing an industrial PhD at Centre Borelli at Université Paris-Saclay, in partnership with the company OnePoint. Welcome, Jean.
Thank you for having me.
Thank you for being here with us. Your early research focused on reinforcement learning applied to intelligent tutoring systems, but more recently you have shifted your attention to large language models, with the current situation, I guess, focusing on teaching framed as a machine learning problem. Okay, I think this is not fully clear for our listeners yet, but we will get into that in a second. But let me start with the following maybe less conventional question. If your research had a theme song, what would it be and why?
So if I had to choose a theme song, I think it would be the Pachelbel's Canon. Because, this progression from simplicity to complexity, it kind of illustrates quite well, I think, the mental process of building new knowledge layer after layer. That's the best I could find.
Okay, so then let's dive deeper into your work and maybe go a bit deeper into this complexity. So what inspired you to actually pursue this particular research topic?
In 2020, I was doing my master's degree on AI. So we didn't have LLMs at that time, but it was already well known, that AI was very good at personalization. And but AI had not really entered the sector of education, at least in industry. And I was quite puzzled by that. I was thinking that, I couldn't understand why we were still learning new concepts the way we did, why AI researchers had not already figured out a way to improve education in a way to make it much more efficient, really, really different from what we've always been doing, in this research field. And I kept thinking about that during my master's degree. I couldn't understand why AI was not deployed already massively for education. So, of course, I wasn't expecting that this would take the form of LLMs, but I had the feeling that once AI would really enter the sector of education, once we would really come up with efficient algorithms for human learning, it could have a tremendous impact on our lives.
It's interesting because I was at a conference of UNESCO in September, and now education is the sector that implemented AI the most of all sectors. So that shifted, I think, very quickly, actually. You said to improve education and to make it more efficient. How would you define efficiency in education?
I think it's very difficult to define. It depends on what you expect for education, what kind of educator you are, in which field are you teaching. But that's always the problem when you're dealing with machine learning algorithms. At some point, you have to come up with some measure of success and failure, and you have to be able to quantify that. Because otherwise you cannot compare algorithm and you cannot say this method or this strategy is working better than this other one. So you have to choose criteria. And most of the time in education, as everyone knows, I guess, we use exams, we use tests, we use Q&A. We know it's biased, and we know its approximations, and we know that it's just one small part of human learning, and it's not enough to fully characterize what people learn. But that's the best we have. And so when we design teaching algorithms and when we design adaptive learning systems, we have to optimize for some metric. And most of the time, that's the kind of metrics that we use. We just do pre-test and post-test, and we measure the difference. And that's how we compare learning algorithms.
Nice, thank you. You already mentioned the outcome of AI and how it changed and how it got implemented into education. How does your research contribute to the issue that the world is facing now, maybe also with the outcome of AI?
It's not easy because I've worked on very different research fields, but I think the problem of teaching, in a broad sense, teaching, meaning so actually the process of selecting pedagogical actions sequentially, I think it's going to be a more and more central problem. So not only for human education, but also in machine learning itself. So first for human education, since ChatGPT came out, everyone has been quite puzzled about its impact. I mean, we don't completely know yet if it's positive or negative. Some people say that it makes the student, lazy. Some people say that it helps them learn faster in a more personalized way. But to me, the most interesting part is that it creates opportunities to learn in different ways. I'm going to give you an example. There is this research line by Manu Kapoor in ETH. So I'm not an expert in this research, but the idea is that they are working on something that's called productive failure. So productive failure is the idea that you learn better a concept if you try to invent it yourself. So the idea is that the teacher, put the students in a situations where they have to solve a problem, okay, and they don't have the tools to solve this problem. These are very difficult problems, and they make the student think about these problems and try to come up with new solutions and try to design themselves the new concepts, for instance, in mathematics, that will help them solve these problems. And most of the time they fail because it's very difficult. And the first ideas that you have usually to solve a problem are not always the best ones. And the idea is that the teacher, the tutors managing the learning sessions are going to help the student, understand why the solutions they come up with are not optimal by showing them their limitations, etc. And it's interesting because there are some evidence that this type of education works super well in some settings, but at the same time, it's very difficult to implement because you need to prepare a learning session, especially for, preparing the students to fail, but fail in a productive way so that they can easily understand why their solution is not optimal, etc. So you need to organize the session, you need to have tutors. It's very difficult to organize. And somehow it looks that LLMs, if we could adjust them in a way of behaving like this kind of productive failure tutors, could help scale this kind of techniques and maybe help people learn new concepts in ways that are completely different from the ones we usually learn them in school. So that's one example. But if you consider technologies, closer to what I'm working on, you can think more generally of combinations of language models and reinforcement learning to build teachers that would not just imitate the way humans teach, but try to do better, achieve somehow superhuman level of teaching. That's the promise of reinforcement learning. And we've seen that happen already in niche domains, such as the game of Go, 2016, I think. But that's really one of the promise of language models combined with RL applied to education. So, okay, that's for human learning. So that's one of the reasons why the problem of teaching is probably going to be more and more important, computationally speaking, in the domain of learning, of human learning. But even in the machine learning domain itself, the problem of teaching is actually important because actually more and more people in the research community consider that the classic method of scaling the models, making them bigger and bigger, and use always bigger amounts of internet data to train these models, it looks like it's starting to plateau somehow. And if we want to come up with new models that are able not only to imitate humans, but to achieve some superhuman levels, for instance, in reasoning, in mathematics, in coding, etc., we need them to be able to evaluate on their own. We need them to be able to synthesize their own training data, which in some sense can be translated in the problem of machine teaching themselves. And this has been very much investigated in research communities such as open-endedness, for instance.
There was so much information. I have so many questions. I would like to start with the human learning you mentioned first, because you said something that LLMs could scale these type of pedagogies. You described the research-based learning with this example of actually the student being in a cognitive conflict and finding the concept and the solution to it themselves. And LLMs could help scaling these. Do you have examples of research where this was done and showed that it actually was efficient or effective?
Yeah. So again, it's not my area of research. So I don't want to speak about it instead of people who are really working on this. But the researcher that I mentioned earlier, Manu Kapoor at ETH, I think it's in Zurich, they were actually able to come up with experiments where they showed that this framework of productive failure actually works in practice on populations of students. They have been able to demonstrate the impact of it. I know they have done experiments of implementation of this technique with LLMs, but I'm not super aware of the results, to tell the truth. So I don't want to take the risk to say anything imprecise.
Okay, no problem. But I think just already the reference, we can look into that.
But for sure, there are big challenges because language models, they have been trained with this reinforcement learning from human feedback system, which somehow encourages them to do what the user wants them to do. And in a scheme of productive failure, for instance, this can conflict with the fact that the LLMs are not there to give the students the solution, even if the student asks them. Mm-hmm. It can be quite difficult, to tweak these LLMs in a way that they really behave like tutors and educators that are just there to make the student think and not give them the solution and not give them too much hints.
Yeah, what right now the LMs often do, you ask them, write me the essay on XYZ, and they actually do it. And there's no really challenging anymore.
Yeah.
On the machine learning side, you mentioned LLMs teaching themselves, training themselves. So I think that's more, if I understand, more of your research expertise. So let me ask the question, what were some of the key findings or insights from your research you could share today with us?
So what we've done is that we've worked on the post-training of LLMs. The post-training of LLMs is basically when you have a pre-trained LLM and you want to fine-tune it on some new task or some new reasoning problems, you have to make it explore and generate its own data to come up with new solutions. So in a way, it's unsupervised learning, right? So what we've done with our team is that we came up with a paper that was among the first papers to formally identify the importance of what we call critical tokens. So when these LLMs are reasoning and generating new trajectories and exploring, there are some tokens for which it's quite difficult for them to output a definitive answer. What I mean is that there are some tokens in their reasoning trajectories where they hesitate a lot, and that has a tremendous impact on the final outcome, whether the LLMs are going to answer correctly or not. And we found out that most post-training methods for large language models based on reinforcement learning with penalties that we call Kullback-Leibler penalty do not necessarily help the model to explore efficiently on these tokens. So what we've done is that we've proposed a tweak to the KL penalty, the Kullback-Leibler penalty, that allows the model to put more exploration effort on these tokens because they are the most important ones for efficient exploration. So that's one thing that we've done. So prior to that, I've worked a lot on AI for human education, more specifically learning path personalization. So I've worked on recommendation engines designed in a way that they could be pre-trained on massive amount of data to make good recommendation faster at this time. So that was a big limitation of recommender systems for education at that time, is that they were either super biased or they would require tremendous amount of data to be able to make good recommendation. And we came up with a recommendation system that was quite data efficient. So it didn't need like thousands of students to be able to learn to make good recommendations. And on the other hand, it had very little bias. So yeah, it was kind of innovation at that time. But to tell the truth, it's been made obsolete by ChatGPT.
Yeah, that sometimes happens in research.
Definitely, yeah. especially today. But so now regarding the problem of teaching in a more abstract way, I spend a lot of time working on a framework to try to unify domains related to the problem of teaching, meaning the problem of taking optimal pedagogical actions. And I was quite amazed to realize that a lot of seemingly different research domains actually address very similar questions if you put them under a common vocabulary. That's one of the recent stuff I've been working on.
Thank you for these insights. That's super interesting that coming from so many different projects actually you are doing. Now, how do you make the bridge between your research that can seem actually quite theoretical and real life? Maybe you have any anecdote or story where your research directly impacted or changed someone's life. Maybe that's a bit too big, but yeah, how do you make that bridge?
Yeah, to tell the truth, not really. I mean, I didn't have much impact on anyone's life for now.
For now, that can still come.
But I think one of the main problems in this research field in general is that, adaptive teaching, AI in education, algorithms for personalized education, apart from a few niche domains, most of the time they don't make it to production. Right, they stay in research, education, which is fine, right? Because it makes the domain progress, etc. But it's quite rare, the amount of algorithms that actually manage to make it to production. And I think one of the biggest surprise actually was that the algorithm that actually had most impact on human education in recent years, maybe since the beginning of AI applied to education, is actually ChatGPT, which is not designed by people who want to improve education. It's not something that came out from a lab of AI applied to education. It's AI in general. And I think it relates somehow to a disposition paper by Richard Sutton that came out a few years ago, I think, The Bidder Lesson, which basically says that the actual algorithms, AI systems that are the most powerful and have the most impact are not actually applied algorithms, but more like very general models with a lot of parameters, working on very general tasks, on a tremendous amount of data, and avoiding making too much bias on the tasks they are trying to solve. So Richard Sutton says that these are actually the algorithms, these are the models that actually have the most impact on education, which have the most impact on applications in general, and in particular in education. So it's a bit deceptive in a way, because the algorithms that have the most impact are always the most generalist one. So it doesn't mean that, of course, we shouldn't do anything in AI applied to education. We shouldn't do anything in applied fields. And I think, being able to precisely characterize what we expect from AI in education, being able to characterize the problem of teaching, what do we expect from teaching, which metrics are we trying to optimize. I think this kind of work, is independent on, the solutions and these big models that come up to try to solve them.
I fully agree. I think you're quite humble here. I think I see ChatGPT used in my classroom with my master students, how it's used. And you have even studies who show that the use of these LLMs, it's being a ChatGPT or Gemini, actually shows a way lower brain activity than doing the same task with Google or actually without any help. So I think it's also good to invest the work, the research in adapt these LLMs to education, to find the good pedagogies and the good decision making to support our learners, because they will use the LLMs in future. I think we can all agree on that. It will not go away anymore, but it's good to have this work to make it better and not just let them use these general systems that might not make them think critically anymore or just reduce their brain activity, which would be a pity. I think these anecdotes and stories, they will come in the future. I'm sure of that. So let's pretend now I'm 20 years old and I want to change the world for the better. Why should I engage in research? And maybe even more precisely, why should I choose your specific research topic?
Yeah, so why engaging in research in general? I think that something very interesting and important about research is that it teaches you to come up with new problems. And I think it's a very important skill. Formalizing new problem, describing it well, characterizing them well, trial and error, work on some problem and then realize that, oh, actually, no, it's not the right problem. This is the problem that I'm really working on. This is the problem that really matters. This iteration, on coming up, building problems that actually make sense. I think it's a skill that's super valuable. Not necessarily the one that we, learn the most in school, but research is really wonderful for that. It always, confronts you to the quality of the problems you're working on, and always, making you try to redefine them and so that they make more and more sense. And on the other hand, AIs, people are really worried about, which skills AI will be able to master in the coming years and what they're going to be able to do. Are they going to replace this or that profession? AIs are getting increasingly good at coming up with solutions to well-defined problems, but we still haven't figured out how to design AIs that create good problems, that ask good questions, good research questions, questions that really matter. So I think it's still something that's super important, and maybe it's going to be more and more valuable in the market. So now, why would they choose my research topic? So first, because it doesn't work. And as I said previously, I think the impact will be huge, not only on human education, but even in AI itself, even in machine learning. As I said, I think the problem of teaching is going to be more and more generic as these AIs become, increasingly good in solving problems and applying our mathematics, etc. We're going to have to design AIs that are able to teach themselves, to generate their own data, to generate synthetic, useful data, which involves, a deep work of thinking and rethinking what the problem of teaching actually is.
I think there's still a lot of work to do, so I'm convinced I'm buying myself in. Okay, I think that's actually the wrap of today's episode of the R&D Unplugged podcast. I'm Annalena, your host. A huge thank you to our guest Jean Vassoyan for sharing his insights with us. And also a big thank you to all our listeners who joined us for today's episode. Thank you so much, Jean, for being here.
Thank you very much.
R&D Unplugged is a Learning Blend Institute podcast. This episode was produced by Annalena Neurohr and Johanna Starr, with recording and editing by Jean-Marc Savin. Don't forget to subscribe to our podcast so you never miss the newest episode. You can find all of our podcasts and further information about all our activities on our website at learningblendinstitute.org/podcasts. Thank you all for listening, and we will catch you next time.
Learning Planet Institute.